The last thing that we're going to talk about today is the remainder theorem. And this is a way to evaluate a function at a given value without having to just take that x value and plug it in everywhere that we see x and solve for y, like we did in the last lesson when we were graphing. So the remainder theorem says that if a polynomial f of x is divided by x minus k, then the remainder r is the function evaluated at k. Now that's a whole bunch of math speak to basically boil down to this. Our remainder, whenever we do our synthetic division, is equal to the function evaluated at that number. So let's take a look here. We're going to use synthetic division to evaluate at the given value of k. Now notice that we are given k this time. We don't have to find k in an expression. We're just given k equals -4. So we're not going to take the negative of this because we've already been literally given our k value. So don't take the negative this time. So they've kind of done the first step for us of identifying the k value. So we will start with putting that k value on the outside of our half box and then seeing if we have all the terms, 3, 2, 1, 0, we're good. So we'll go ahead and write all of our constants and coefficients. Remember to leave yourself some space here. I don't want you to think that this is a -11 and a +3. Be sure that you're leaving some space there for yourself. Same process as before. Bring down the 5, multiply it by -4 to get -20, add -21. -21 times -4 will give me 84. And I will add 84 and 13 to get 97. These numbers are getting a little big. You may want to grab a calculator on some of these types of problems. And finally, 97 times -4 is going to give me -388. And when I add 29 to that, I'm going to get -300. And when I add 29 to that, I'm going to get -359. Now, instead of writing our entire quotient and remainder this time, remember we're using synthetic division as a way to evaluate our function at a value of -4. And so the answer to this is -359. So this is the way that we write our answer. We say that we are evaluating our function at -4, so f of -4 is equal to -359. Let's prove this to ourselves. Let's do it the way that we have learned up to this point. So until this point, what we learned was that in order to evaluate a function, so we're going to evaluate the function at -4, this is what we would do. We would write our function, but everywhere that we saw x, we would plug in -4. So we'd say 5 times -4 to the third minus -4 squared plus 13 times -4 and then plus 29. Now, if you put all of that in your calculator, being super careful to get the negatives in the right place, all the parentheses in the right place, all of that, you should get -359, just like we did up above. So this is kind of our proof. You don't have to do this every time, but I just wanted you to see it once to know where this is coming from and what we're really talking about. So this is our answer, and notice that it's the same value here. I'd like you to try number 5 and then come back here to see how you did. Okay, let's take a look. So you should have tried to confirm that we had all of the terms. 4, 3, 1. Ooh, we're missing that x squared term. So when we come down here and write everything in our box, we need a 0 here. This is probably the number one error that I see happen whenever I look at incorrect answers, is forgetting to do the 0 placeholder. So don't let that happen to you. Always be sure to check. We're going to use our house number or our k value of 2 and start our process. 5 comes straight down and we multiply 5 times 2. We get 10, which we will write up here. 2 plus 10 gives me 12. 12 times 2 is 24, and we write it up here. Remember, we're always going up and to the right. Adding straight down, we get 24, and then we're ready to multiply 24 times 2 and get 48. Negative 20 plus 48 is 28, and times 2 one more time will give us 56. Negative 6 plus 56 is 50. Remember that when we're using this to evaluate, the thing that we are interested in is right here, our remainder. Our function evaluated at 2 is equal to 50. You can prove this to yourself by taking 2 and plugging it in everywhere that you see x in the equation, and you should come out with that same number of 50.